Okay, let us resume and kind of think about where we're going to take this next. So we found a way to go through and get an average solar directness value, okay, for each of the different surfaces, or for, at least one of the surfaces at a time, okay, for each of the different iterations on what the rotation might be. And that's going to be very useful for us because we can now go through and start to think, okay, if we can figure out what the solar potential, as one of the things we want to look at, is for this building for each of those variations, we now have a way of starting to think about, what a good shape might be in terms of maximizing that. Now, the trick to this is as our tower twists around and starts moving from 20 to 30 to 40 and gets up to 90 to 120, if we only look at a single surface, it may be getting worse, but what could be happening is another surface could start getting better because it's twisting around to the point where some of that surface is now exposed to the sun when it didn't used to be. So it's not enough to just go ahead and consider one surface. If we really want to be thorough about this, at least in terms of the sun directness and this twisting issue, we have to start thinking about more than one surface. Now, you could be optimizing a lot of different things that only involve a single surface, and that's okay. Then you don't need to go through this complexity. But in particular, just because of the problem we chose to tackle as an example, I need to start thinking about more than a single surface. So let's think about how that can work. Now, as we're working here, let me also comment something about the whole Dynamo environment and how it works. The interesting thing about Dynamo and how it works is that you have this what's considered the home view, the home environment, which kind of has the highest level scripting, but we also have all these little custom nodes which are called either directly from the home view or called through a node which is called from the home view. And the interesting thing is they all get evaluated. So even though they are not open, they're still being evaluated. So you can actually keep a lot of different things open and segment your work into these different custom nodes and be watching the nodes independently. So even though we're reporting values at that highest level, okay, we can go ahead and put a watch in here to report values in these sublevels if we're interested in actually seeing the values that are coming out along the way. And that really is very useful for us for debugging. And you can kind of open these nodes and kind of keep track of what's going on independently as the logic sort of rolls up. Okay, so here's what we need to do next. We need to go through and have the evaluation of 3 different spaces, not just a single space. Okay, and we'll think about how to do that. It's really not too awfully bad. You might imagine that if we can evaluate a single space using this logic, about the only difference between, the phase 1 versus phase 2 versus phase 3 really is right over here. It's just this part where it says change on select space, where we need to be selecting the different spaces and gathering all 3 of those values at once. So it's a little tricky. We can't just go ahead and do that in a single function. We could try and set up something that's going to iterate through those spaces. What I did to approach the whole thing is actually to set up 3 different versions of this function, one that evaluates each of those different spaces, and that kind of gave me a very easy way of getting at what we needed. So let me kind of show you what we have in mind there. So back over to 14.1, if you switch over now from step 2 to, I think it's step 3, or maybe it's step 4. Hang on, I'll tell you in a second. That was step 2. Let's see what my step 3 is. Step 3 is, I think, when I'm just reporting the values out. So I don't think that one's going to be critical. Let's go to step 4. So here we are. This is going to look amazingly similar to you in terms of what's going on. This all looks about the same in here. Looks like in this version, I may have actually finally just cleaned up that stuff that's at the top. We don't need that independent evaluation of the sun because we're doing it actually as part of our custom node. Let me close up some of these other ones here just because it's going to confuse me about which ones are actually active right now. And starting with this step 3, all the action that we care about is happening in this one big node here. You'll see it has a very slightly different name. It's just 2 parameters plus sun, multiple faces. Let's talk about what we did in that. What we did for this thing is actually just, if you open the node, kind of set up some more branches. So we had already added a branch that would go through and calculate the sun directness to a face, and we did it for a single face. In this one, what we're doing is we're actually just sort of cloning that function. I'm actually making 3 different functions, one for face 1, one for face 2, and one for face 3. Then ultimately, just bringing those all 3 out and reporting them as CSV values. Okay, so now it'll be the parameter to test. That's the rotation. One's the gross floor area and one's the gross surface area. And now we're going to have these 3 different values for the faces in terms of the sun directness for those faces. So I'm going to end up with basically 6 columns of data for each row, where each row represents like one of those iterations that we were testing. And each of these actually look amazingly similar. If you open up one of these and edit the custom node, okay, it's really the same node. There's not a whole lot of change in here. The only thing I'm doing that's at all different is just setting it up so that we use the sun path, and I change, and I choose the face that I want to be associated with this first function. So that'll be that one. I'll do the same thing for the other 2. So that's get sun directness for 1. Let me go through and get sun directness for face 2. I'll edit that. And notice I'm just going to keep them all open. So again, I'll say use the sun path, and I'll change again to that rotation. I'm going to go sideways or go clockwise around it and say face 2 is the one behind me right now. And then finally, over here, we'll go back and open up the one for face 3. And then we'll choose the face 3 and associate it with it. And I just bet you, there's probably more sophisticated ways of doing this in terms of feeding the faces to it. This will work. This is kind of expedient, but we'll keep on working on a more elegant way of passing those faces so that we don't have to kind of define these 3 separate functions. But this is going to work for us for today. So I'm after that face. Okay, beautiful. So I got these 3 different functions. Hopefully it's going to report 3 different values. And then we're going to string all those different values together, concatenate them together into this big CSV string. The whole CSV string for 6 values. I think you guys probably got the general hang of that. Yeah, so I probably don't need to belabor it. But if I open it, you'll see that it just has even more of those things. Actually, let me do this, just so you actually sort of have, in terms of as I can, clone all these functions, just give you a little tip in terms of working with Revit or working with Dynamo for doing this. Let's say, for example, I wanted to create one that actually had 7 values. And again, there's got to be a more elegant way to do this than what I'm doing right now. But what I can do is say, save as for this custom node. Just save it to the 7 value version. I'm just going to show you this in terms of how I clone functions pretty easily. So I'll save that away. It doesn't really have what we need in there just yet, so I'm going to add a couple more inputs to it. Or I'm going to put the comma in there to separate the last value out. And then what I typically do is just go through and I'll grab these 2. And I'll copy them, Control C, and I'll paste them. Control V. That'll show that it's expecting data value 7, and I'll put it in here. So that's all I'm doing in terms of cloning new functions. There's really not a whole lot of magic or mystery to it. But in order to get it to show up on the list, you notice that in my little CE 120 bucket, okay, it actually is showing up there right now because I've sort of edited it this time. If you don't have things showing up in the list, what you can always do is if you say edit the node properties, that just gooses things along so that things will show up in that list if they're not there already. There it is, hanging out. Okay, so now I could use that one. We don't need 7 values. I just want to show you how we do that because even in terms of cloning this, selecting the face 1, selecting face 2, selecting face 3, that's all I did. I just did a save as and then just re-imported the new node. Okay, so let me pause there for just a second, sort of see, does it sort of make sense about where I'm trying to go with it in terms of getting a value for each of the different things that I want to measure and concatenating those together? Let's see if anyone has any questions about that. And if not, or actually, how about this? I'm going to go ahead and start it running since it seems to take a long time for it to run for me, and then we can answer any questions as it's running. Please go ahead and run it on your side too. I think you'll get answers a little bit quicker. So let's go ahead and sun plus multiple faces. That doesn't need to change. Let's go ahead and, 20 to 40, that's kind of okay. Let me do 20 to 30. I'm tempted. I'm going to say 30 just in case it takes a real long time. For you guys, since it's going really quick for you, go ahead and if you want to make that 20 to 120 or 45 to 135, whatever you want, go ahead and do that. It'll run quick enough. You'll get a lot more interesting data out of it. But go ahead and just try running it. Let's see how it goes. So I'm going to say run. Okay, again, I'm just going to compute a couple different iterations. You guys can compute a whole lot more. And as that's running and doing its thing, let's go and see if anyone has any questions about what we're up to. None here? Okay, excellent. If it's sort of making sense, that is super. Don't be shy. Go ahead and there are no bad questions about this stuff. I worry sometimes that this is all getting a little esoteric or a little abstract, but yeah, if it's resonating and you sort of get the idea where we're going, then super. You're going to be in great shape. Okay, as we're waiting for this to finish computing, then let's even kind of beg the next question though a little bit in terms of thinking about this. Okay, because if you've run it on your side, you might be able to see that for all your different values, you have now the series of different solar directness values. You know, some are less than 1, some are greater than 1, some may be very strong, some may be very weak. So you have these 3 different values for each of the different rotation options, or each of the different rotation possibilities. So the question is, really, how would we like to consider that? What do we think about as really being a good way to factor those values in? We actually have 2 other values. We have gross floor area, gross surface area. Maybe those won't factor into our consideration as we're evaluating the sun. Those would be more about building performance or kind of some surface efficiency. But if we were just thinking about the surface of the sun, or the surface and how they're kind of oriented relative to the sun and the exposure they're getting, let me leave it to you, throw it to you guys in terms of how would you think about, going through and constructing a measure that can take, all these things into account? And I'm just going to wait for a minute and see if anyone has any suggestions. Please don't be shy. Type something in. How would you think about if we have 2 or 3 different values? What would be a fair way of evaluating this so that we could actually take into account multiple different factors? Again, don't be shy. Go ahead and suggest anything you can there. It's like, yeah. So, Raj or Pratush, any ideas from your end? Or, you know, I have ideas, but I'm quite curious to sort of see, because this is where it really gets to be there's no right answer or no wrong answer. It's really just a matter of kind of, as engineers, how we like to think about it. Waiting? No, waiting is actually a good way to think about it. So let's kind of think about really what we could do. So you see I start to have different values. For the surface that's closest to me right now, it starts moving from 1.57 to 1.56. The surface that's behind a little bit, it's moving from 1.09 up to 112. It's getting a little more favorable. The one that's kind of, in like the 1 o'clock position, or it's just sort of off in the upper right-hand corner, it's getting a little less. So these values are moving in different directions. So as you think about weighting, what can we do? You know, there's all these things. What could we do? We could say, you know, how would we weight them? We could all just add them together. Surface area is another one. Well, let's think about, how can we bias this? It's really because, there's different values there. This is almost like a good Excel exercise to figure out really what returns the best values. I could add them all together, but, then if some things are getting better, other things are getting worse. I could just go ahead and, what would it be? You'd almost look for, what is it? It's I'd want to give the one that has a favorable rating, like more weight than the ones that are kind of in the shadow, because I'm sort of really trying to maximize that more than the others. I don't know. I'm really, I'm open to almost any and all suggestions about how we can do it, because it's really now just a matter of some sort of simple math. We could say that we want to get the average of the averages, if that sort of makes sense, that you sort of say that there's a composite average of the averages for all three of the sides, and we're going to look to try and make that better. It could really almost be any different criteria, and that's really, one of the thought questions to think about on the assignment is really how, when you have all these different criteria, you think about doing that. Whether it's sort of a simple mathematical relationship. For a lot of you who've looked at, the whole MacDaddy sort of methodology, there's a way of basically plotting different values based upon different evaluation criteria, and then looking at the area within a space that is kind of enclosed by plotting those different values. And we can set up something to do something like that. What do I want to do here? For what we're doing here, I have no idea whether it'll be a good sort of overall evaluation or not. Let me just try taking the average of these things. I'm trying to think if multiplying would help. Now, let me do an average or something like that. But again, this is one where it's going to take a little thinking to kind of figure out really what the right criteria is. So here's the deal. We have a bunch of different values here. We have in columns, if this is 0, 1, 2, it's columns 3, 4, 5 are really where these different values are. We can start thinking about trying to do some sort of calculation between columns 3, 4, and 5. And in terms of doing that, we had an example down here of computing a ratio between columns. Let's go ahead and think about doing an average between columns. Let's kind of even think about it. Okay, compute the ratio between the columns. Let's go ahead and just set this up and see if we can actually make this work. So what I'll do is we have columns, that's the numerator, the denominator, that was for doing that. Let's go ahead and set something up a little bit differently. And the number range there, that's going to be okay. That's the number of things in the list. That we do want to get, because we're going to evaluate all those things. Let's go ahead and change this function around just a little bit. Let's kind of edit this custom node and we'll create a new one. I'll call this, let's for example call it like compute average of 3 columns. And what you're going to find is very often I'll do it this way to get started, and then as we get a little more facile, I figure out a way to do it a little more elegantly, as opposed to making all these very explicitly named functions. But let's figure this out. Okay, So what we're going to do is just kind of think about grabbing some different things from the list. What we're going to do is basically pull rows off the list. That's going to stay just the same. We're going to pull some different values out of it. So we'll say column index of, let's say face 1. I'll say column index of face 2, and you can just bet that I'm going to say column index of face 3 in just a second here. Change that around there a little. Okay. Let me go through and copy those two, because it's pretty similar. I'll say the column index of face 3. Okay. By getting from the list at these different indices, okay, that's going to get the value. That's going to get the value of, face 1, face 2, and face 3. It's going to be like a face 2 value. And I won't change them all right now. I think you'll get the idea in terms of doing that. Then we're going to want to do some sort of computation between the three. So what can we do? How about for a formula, we're going to say value 1 plus value 2 plus value 3, divided by 3. And again, this is not the most elegant way to do it. Actually, even in here, that's not going to work in terms of, I think we need to put some parentheses in there. Hopefully that'll compute an average. So I'm going to go through and say that, great. Now, what are you complaining about here? It doesn't like me. Mismatched input 1. Got that. Now let's replace it with a new formula. I get sort of confused. Formula, let's try again. Okay, open paren, value 1 plus value 2 plus value 3 divided by 3. That's looking a little better. Got it. So now we got to figure out really what we want to return. In terms of actually grabbing those values, I could just return that average, or I could return all of the original values as well as the new average of the three values. Maybe I'll do that. That actually feels like a fair way to do it. I'll return this plus one more item, which is the average. Okay, so this is going to return the test value, the three different values for face 1, face 2, face 3, as well as the average. Does that make sense? Okay, and this is going to be average. Well, actually, it's really it's the list with average face values. If I want to get really explicit, in column 4. And again, I'm just being that very explicit right now, just so it's very clear for us if we're doing what we're doing. Let me edit this custom node properties. That's just going to help me compute average of 3 columns of values. Can we pause there for a second? Oh, yeah, the space. And oh, thank you, Henry. I never figure stuff out like that. Yeah, I can't see it when I'm typing. So thank you. Like, that's very, very helpful. That was the problem. Very good. And close that up. Save your changes there. Nah, I don't care about 7 values. What I'm going to do now is back over in the overall function here, as opposed to just computing the ratios between the columns. Let's go ahead and do this a little bit differently. We'll go through and in my CEE 120, where'd it go? Not in form. Collection of goodies. Throw that in there. Okay, we're going to go through and basically let the row index be the thing that's going to change. That's the thing we're going to go through and evaluate row by row. So that's not going to change. That's going to happen out of the mapping function. Okay, in terms of the column index of face 1, that was column 3. The column index of face 4, or face 2 is 4. Interesting. The list needs to be plugged in too. In terms of the list that's going to get plugged in, where did it go? It is really, it's this list right here. Okay. And then, oops, I'm doing the wrong thing. Right there. Oh, wrong. I have to plug it into the right input right there. And finally, the column index of the last one, I'm going to put that up here and get it out of the way, will be 5. So I'll just copy that. Put that in as the column index of face 5. Beautiful. Excellent. I get rid of this guy now. Because what I need to do is basically use this function, and I'll put in all the different rows there. Okay, so this is going to return basically a big old list of all the different values for the 3 different columns. We're looking pretty good there. And now we're basically go through and we're able to, what is it? It's going to return just basically a hierarchical list. So from that, we can now plug in and take this list and grab different values out of it. For example, if I want to go through and do it based on, what is it? This list, okay, and pull the maximum value out of my new list and say that the column index that I want to try and pull it out of is, what did we actually return? We just returned test value, face 1, 2, 3. So it looks like I think it's just column index 5. Hang on here. Okay, that'll get the extreme values of this list of column 5. And from that, we can go through and do our computations, figure out the high, figure out the low, and then based on that, whether we're going for the maximum or the minimum value of the average. In this case, I would probably go for the maximum value of the average. So I'd go for that one instead. I'd say, let's plug that maximum in as finally the value that we want to use for resetting the actual element. So what this is all going to do is go through, figure out the maximum of those average values, and then finally go through, just go through and like, adjust the tower. So it kind of assumes that shape. So I'll let you go ahead and do that one in terms of actually doing the calculation, in terms of running that on your own, but that'll actually work out pretty well for what we want to do that. Let me go ahead and save this away, because that's actually a pretty good one, and I'll even post that with the example to update that, because that's a pretty good little chunk of logic right there. Step 5. we will take it one step further just in our last minute here to say, great, we've had a fantastic time thinking about the sun. The sun's a good thing to be thinking about, but what if we actually had something else that we were concerned about? Okay, just something as opposed to the sun, but instead just like, a location, something like that. Let me kind of just give you an example of how that looks. Let me close up Dynamo and give you an example. So for the second part of the assignment, we say, hey, go ahead and think about the view towards some object. And to simulate that object, you can put anything you want in there to represent it. I'm just going to put this little box into my space. Okay. And that's going to represent my fabulous object that I want to see, whether it's the Eiffel Tower or the Statue of Liberty or the Freedom Tower or whatever it is. I thought it was going in there. It's just flashing around on me, I think. Try again. Beautiful. Okay. How do you figure out where this box is so you can use it? Because we've been doing all this stuff about figuring out where the sun is. We have this great function for figuring out where that is. How do you figure out where the box is? Or in this case, your fabulous landmark that you want to take a look at. And here's how you do it. If it'll stop kind of flashing on me for a second. What we're going to do is use a combination of just getting properties about that and sort of get location to make that work. And let's see if we can illustrate that real quickly for you. Because really based on that, you can swap this right in for everything we've done about the sun for evaluating the location. So it's going to start with this whole notion of selecting a family instance. And that's just an object we want to grab. So let me go ahead and grab that. Okay, the box is selected. You might say, how can I figure out where that box is? And there actually is a very good function for you. Let's try this. We'll say location. Get family instance location. I love this. What does it do? It returns X, Y, Z coordinates of that family instance. So I can do that. So if I go through and run this, with any luck, it'll return some X, Y, Z coordinates. Very good. And if I go through and move this box around to any other location, indicating another location where it could be. Again, when I run this, it's going to return the new coordinates of it. So for the second part where it says, can you see something? Can you see its view? Or how direct is your view of that object? That's all we're going to do, is really use the same sort of logic. And instead of plugging in the sun's location and computing the directness to the sun, we're going to be computing the directness towards wherever this object is located. And here it's very close to the building. You can put it close to the building. You can put it far away from the building. But it's quite interesting to see what happens as you move an object around to see how the building adapts and changes its width to sort of maximize its view of that object. Okay, so that's part of the second part of the assignment. I think you'll actually have some fun with it. It really is kind of fun to watch what happens when you put that all together. Okay, so let us kind of see if there are any last questions for today. But I think that should be plenty of stuff to get you going in terms of what you need to do with the assignment. I think we got all the essentials out there, so it's like mostly now just jumping in and practicing with it and having some fun. Anything from the room or anything from folks hanging online? Yes. Now, that's a pretty good assumption, Henry, that you would weigh one face more than the other. Oh, based on the surface areas. Oh, that's actually a very good way to think about it. I hadn't really considered it from that area. Since my building has fairly even surface areas, I don't think about weighting it that way, but no, you could. You could put a weighting factor where you grab the surface area value and you multiply that by the average value to kind of, give it exactly. No, you're thinking absolutely right, Henry, in terms of, so what Henry is suggesting is that one way to think about the faces is to weight the faces based on the total amount of surface area heading in that direction. And that's actually perfectly valid. Since mine was unidirectional, I didn't really think about it that way, but no, you're correct. That way, a face that has an awful lot of panels, an awful lot of surface area, facing in that positive direction would be weighted more heavily. So, the way we've evaluated the panels and quads is the same on each face. We're just getting an average, so it doesn't really matter how many panels or quads we put on there. That just really controls the fineness of the analysis. But I think that you're quite correct in that adding a weighting factor based on the the size of the face, really is a very good, thing to throw into the consideration. So I second what you're saying. I think that's a really good approach. Okay, any other last questions? Okay, let us adjourn for the day. Any other questions? Please just go ahead and send us an email message, and we will just kind of keep it moving.